guys, how's it going? So today we're going to talk about balancing a little bit more, but now we're going to start talking about word equations. So you guys have been the last couple of days already balancing equations using coefficients, and we know that a balanced equation on each side of the equation has the same number of atoms. Same number of atoms, not molecules. Okay. Number of atoms is what's conserved, not molecules, which so like, H versus H2. This is an atom. This is a molecule. All right. Okay. Now, sometimes a chemical reaction is given to us in a form of words or sentences. So here's where bonding comes back. So bonding and naming is the name of the game now, okay? So using the rules for forming compounds, which we learned last semester, we're going to write each compound in formula form. Now, elemental metals, so just metals, if there's a metal by itself, and nonmetals are written as single unbonded elements. So for example, if something says like copper metal, you would just write Cu, or if it's sulfur, you would just write S. Now, if we remember and think back to last semester, there are 7 unbonded elements that form diatomics when they are alone. It's these diatomics which are listed on your periodic table, so you don't even have to memorize them. They're all right here. The Brinkelhoffs or the Hofbrinkels. So when you see something in a word equation that says hydrogen, you're always going to write H2. If it says oxygen, you're automatically going to write O2. If it says iodine, you're going to write I2. And when the term air is used, we're going to assume that they're talking about oxygen or O2. Now, plus signs and arrows represent something. So plus signs are going to be stand in for terms reacts with or and that's what represents our pluses. And then the arrows stand for things like produces, yields, forms, and that's what represents the arrow. Then once you've written out the equation, then you're going to balance the reaction using the rules that we've already learned. Okay, so first example here, we have, sorry, I kind of wrote over it. We have iron 3 chloride and calcium hydroxide. So iron, Roman numeral 3, if you think back, if it's a metal and a Roman numeral, this right here tells us the charge of that metal. So if we have iron, Roman numeral 3, that means we have Fe plus 3. Chlorine or chloride, we have to go and look back. And chlorine is in group 7. So chlorine is Cl minus 1. Calcium is over here in group 2. So if it's in group 2, it's plus 2, Ca plus 2. And hydroxide is a polyatomic, and hydroxide is here, so it's OH minus 1. Okay, so I'm going to take these ions that I just found, and I'm going to start to write them down here so I have my reaction, and I'm going to bond them. So if I have Fe plus 3 and Cl minus 1, this does not cancel. So what do I need more of? I need a total of 3 Cl's to cancel out my 1 Fe. So it's FeCl3. I keep the plus sign, plus calcium hydroxide. Calcium is plus 2, hydroxide's minus 1. These don't cancel, so what do I need more of? I need more hydroxides. So it becomes CaOH2, and then I keep my arrow. There's my arrow. Okay, what you also probably want to write in front of these formulas are the little spaces, because eventually you're going to have to balance. Now I have to write my product side of my reaction, but I don't even have to look up any of the charges again because I wrote them all up here. They already exist right here. So iron, Fe plus 3. Hydroxide is already OH minus 1. Calcium is right here, Ca plus 2, and chlorine is minus 1, Cl minus 1. So I don't even need to refer back to my periodic table if I don't want to. But I do have to rebond these things. So if I have Fe plus 3 and OH minus 1, those don't cancel. So what do I need more of? I need more OHs. How many OHs do I need? I need a total of 3. So this becomes FeOH3. Keep the plus sign, plus Ca is plus 2, Cl is minus 1. Which one do I need more of? I need more Cl's, so it becomes CaCl2. All right, so that's taking the words and turning that into the formula. Now what we have to do is we have to balance. So balancing is the exact same as before. I'm going to make my atom inventory, make my list, and OH is in parentheses on both sides, so I'm going to keep it in parentheses here. Fe is 1, Cl is 3, Ca is 1, OH has 2, Fe is 1, OH has 3, Ca has 1, and Cl has 2. So this one's pretty easy fix. What I'm going to end up doing is I'm going to end up putting a 2 over here to make Cl a 6 and make Fe a 2. I'm going to end up putting a 3 over here to make Cl a 6, but that also turns Ca into a 3. Then I also need to fix OHs and my Ca. So Ca needs to be a 3 and OH is going to end up being a 6 because I have a 2 and a 3. So 3 goes here, turns this into a 3. Then 3 times 2, this is 6. And then over here, I need 2 Fe's and I still need 3 OHs. So in order to do, 6 OHs. So to do that, 2 Fe, 6 OH. There we go. My ratio for this equation is 2 to 3 to 2 to 3. Okay. All right. So that's how you do this type of problem. I'm going to move on to the one that's in the sentence form. I'll come back to this one later and do this one later at the end of the video. But I'm going to do this one first. So this one, the nice thing about these two is you're given the plus signs and the arrows. All you have to do is do the bonding. In these, you have to figure out where the arrows and the plus signs exist. But it's easy because I gave you the clues and gave you some of the words down here on what you need to look for in order to help you figure that out. So that's what I'm going to do first. So this sentence says, if potassium chlorate is strongly heated, it decomposes to yield oxygen gas and potassium chloride. So decomposes to yield. Yield is something that I'm looking for. And yield, as we saw over here, yield stands for the arrow. So I'm going to put the arrow right there. And if I look before the arrow, there's only one molecule or one atom, one element, one reactant, right? Which is potassium chlorate is strongly heated. It decomposes to yield. That's the first thing I came to. Oxygen gas. So here's my first reactant. Then my arrow, oxygen gas, and what does and stand for? And is the plus sign, potassium chloride. Okay, so I have one reactant, then my arrow, then two products. So potassium chloride, I have to figure out what that is. Potassium, as we already know, is in group 1, so it's +1. And chlorate is a polyatomic, and chlorate is ClO3 -1. Okay, so I'm going to start writing that out. I have K, and so since these cancel, K +1 and ClO3 -1. Then I have nothing else, so I have my arrow. Don't forget to put the line. Then we have oxygen gas. Now, oxygen gas is just oxygen, right? But can I just write oxygen like that? No, it's a diatomic. I have to write oxygen as O2, all right? And plus sign, potassium chloride. Potassium is K +1, and chloride is chlorine, which is in group 7, so it's Cl -1. So these two already cancel. I get space K, Cl. All right, so that's how I go from a sentence to the formula version of it. Okay, then what you're supposed to do, then you need to balance. I'm not going to balance this because you guys already had a lesson on how to do that. So I'm going to jump back to this one, and then I'm going to do the ones on the back just so we can go from the word format to the formula format. All right, so really quickly, let's get through this one. So we have sodium hydroxide. Sodium is Na +1. Hydroxide, here in your periodic table is OH -1. So these two can just be slapped together. Plus sign, hydrogen sulfate. So hydrogen is H +1. Sulfate is a polyatomic, which is here, SO4 -2. Okay, these do not cancel by themselves. So what do you need more of? You need two H's. So H2SO4, arrow. Water, we already know what water is, H2O. Plus sodium sulfate. Sodium, I already found the charge for, which is Na +1. And sulfate, I already found the charge for, which is SO4 -2. So I don't even have to look at my periodic table because I already wrote it. So these two do not cancel. What do I need more of? I need 2 sodiums, Na2SO4. Then you would do your atom inventory. We have a polyatomic here, right? But this polyatomic exists here, but it does not exist on the other side. So you have to split up your O and your H. We have SO4 existing here and SO4 existing here. So SO4 is going to end up being in your list. I'm not going to balance this one because I don't want to waste time on that. You guys already know how to balance, so I'm going to move on to the back side. All right, next one. This one says iron burns in air to form a black solid. So here we need to figure out what are our reactants, what are our products, and where are our plus signs and our arrows. So this says iron burns in air. We already know that air, we're going to assume is O2, and iron is a metal, which is Fe, right? To form, what do you think to form stands for? To form is our arrow. A black solid, which is Fe3O4. Okay, so this is our product. What do you think our reactants are? Fe and O2. So what should go in between these two? Well, the burns in actually stands for a plus sign. So when I write out this reaction, it ends up being Fe plus O2 arrow. This is already given to you, Fe3O4. Okay, then you would make your list, you would balance, move on, figure out your coefficients, your ratios. There you go. All right, last one. This one says sodium metal reacts with chlorine gas to form sodium chloride. So sodium metal reacts with chlorine gas. Okay, reacts with. What does reacts with represent? Reacts with represents plus sign. To form, what does to form represent? To form represents the arrow, right? Okay, so now we need to figure out what are our reactants, what are our products. Sodium metal. Sodium metal is not a diatomic, so I do not need to write Na2 because Na is a metal, it can stand alone. Just write Na reacts with plus chlorine gas. Chlorine is a diatomic, so I do have to write Cl2, chlorine gas is Cl2, to form, here's my arrow, sodium chloride. So here's my little line. Sodium is Na plus 1, chloride is Cl minus 1. So these already cancel, so my formula is NaCl. Okay, then I'd make my list, balance, figure out my ratio, and then move on. All right, so that's how you go from words to the actual like formulas. So remember, things like burns in, reacts with, and those are going to represent the plus signs here. Anything that says to produce, to yield, forms, those are going to be your arrows. So you want to look for anything that looks like it might be a reactant and anything that looks like it might be a product. Okay, so you guys are going to move on to the balancing worksheet. It's important that up until this point, you really know what you're doing because you do have a proficiency quiz coming up, and knowing how to balance and being really strong on how to balance is going to greatly help you the remainder of this unit. All right, have a great day, guys.